This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here.
Hi, my name is Vasil Lombrozo, and I'm very pleased to be introducing the topic of this tutorial segment, Psychological Foundations of Human Explanations. From a young age, explanations are central to human cognition. Children start asking questions almost as soon as they can speak, and often their questions are requests for explanations. We know from research in psychology and the cognitive sciences that explanations continue to play an important role throughout the lifespan, not only in communicating and coordinating with others, but also in guiding our own learning and reasoning, including the construction of deeper understanding and better models of the world. Investigating human explanation in everyday cases prompts two important observations. First, explanation is incredibly selective. We only seek explanations for a small subset of our observations, and we only find some kinds of information explanatory. On the other hand, explanations are also incredibly heterogeneous. We explain a variety of things in a variety of ways and for a variety of reasons, which makes it challenging to offer anything like necessary and sufficient conditions for an act or string of text or other representation to count as an explanation. To illustrate, consider two explanations for why the chicken crossed the road. That the chicken crossed the road to practice social distancing or to hug the vegan. These two explanations differ in content, but they have the same form. They both offer the function or goal of the chicken's behavior, constituting what psychologists call a teleological or functional explanation. But the same event could have been explained in a number of other ways. For example, one could offer what I call a mechanistic explanation, citing a proximate cause, such as a fox that scared the chicken across the road, or a formal explanation, for instance explaining that the animal crossed the road because it's a chicken, and we all know that crossing the road is what chickens in jokes do. Or we could offer what Sarah Aronowitz and I call an experiential explanation, which could contain elements of all of the above, but weaves them into a story with temporal structure and sensory detail. It gets even worse, because each of these types of explanations can be offered at different levels. For instance, explaining why the chicken crossed the road by appeal to its psychology, its biology, its physics, and so on. The cases we just considered all involved heterogeneity in the answer to a given question. But once you vary the question, the potential for new kinds of explanations emerges. For instance, instead of asking, why did the chicken cross the road? We could ask, how did the chicken cross the road? How do you know the chicken crossed the road? Or, why do chickens in general, not just this chicken in particular, cross roads? I've gone through these cases to give you a sense for how diverse explanations can be, even when we restrict ourselves to answers to why and how questions. Yet, despite this heterogeneity, the selectivity of explanation makes it clear that not everything goes, and in fact there's systematicity to the explanations we seek and accept. This systematicity reflects the psychological mechanisms that operate in human explanation seeking and evaluation. Although there's no single agreed upon definition for explanation that captures even the small sample of cases I just considered, there are some common themes that capture a large proportion of central cases and shed light on how these psychological mechanisms operate. So what are these common themes? First, explanations differ from mere descriptions or predictions. These alternatives are helpful because they draw attention to something that seems to be distinctive about explanations in contrast to mere descriptions or predictions. Namely, they offer a sense of understanding. Of course, this just prompts the further question, what does it take to generate a sense of understanding? Here accounts of explanation differ, as do accounts of understanding. But I think we can go a long way by focusing on the fact that explanations are contrastive and identify a difference maker, very often a cause. I'll explain what I mean here with an example. In our original case, I asked, why did the chicken cross the road? Although it wasn't explicit, the implicit contrast was with a situation in which the chicken did not cross the road. But the same question could be asked with any number of other contrasts. For example, I could ask, why did the chicken cross the road, as opposed to the lizard? Or why did the chicken cross the road rather than crossing the bridge? Each of these explanation requests involves a different contrast, and so a different explanation is likely to be appropriate. Part of the complexity of human explanation comes from the fact that these contrasts are often implicit, with humans inferring the missing parts of an explanation request from background knowledge and context. Let's turn to the idea that explanations identify difference makers. Consider again our original contrast. Why did the chicken cross the road as opposed to not crossing it? This sets up a contrast between the world in which the chicken did cross the road and a counterfactual world in which it didn't, where each has its own causal history. A difference maker for this contrast is a factor or set of factors in the actual world that made a difference to the generation of the actual versus the counterfactual outcome. For instance, if a fox scared the chicken to cross the road in one timeline but not the other, that's a difference maker in this case. For this example, the difference maker is a cause, but in other cases, such as mathematical or logical explanation, the difference maker might not be a cause, but rather a fact that makes it the case that one conclusion follows rather than another. One feature of this approach is that explanations will typically refer to only a tiny subset of the causes of an event. For example, we won't cite the Big Bang, even if it's in the causal history of the event we're trying to explain, because it's not what we identify as having made a difference to the occurrence of the actual versus counterfactual situation. We've just seen one reason why explanations are underspecified. They don't need to identify every element of a causal chain. But explanations are also underspecified for other reasons as well. First, communication of all forms is typically incomplete. We say just enough for our intended audience to infer the answer to their question. So for example, if someone asks why you're whispering, and you point to a sleeping baby, that's enough for them to infer that you're being quiet so that you don't wake the baby, and you already know that loud noises might wake the baby, and that it would be bad to wake the baby, and so on, without having to explicitly make all of those claims as part of the explanation. Another reason why explanations are typically underspecified is because they're generated under conditions of ignorance and uncertainty. I might explain that leaves are green because of chlorophyll, for example, with only the most rudimentary understanding of what chlorophyll is, how color perception works, and so on. And yet there's good evidence that for many everyday cases, that's enough to generate a sense of understanding. To make this concrete, I'll give you one example from my own research. In one study, participants read short vignettes about a strange behavior based on a culture-bound syndrome recognized in the DSM. For example, some participants read, "Randy's a 40-year-old male. Recently, he took a beautiful and expensive painting from his office after one of his coworkers said, 'You should take that painting. You're the only one who ever looks at it.' Randy's coworker had not been serious." In one condition, they then learned that Randy has a condition that is defined by a tendency to imitate the actions of others and obey commands directed at them, leading him to take the painting. In another condition, the only difference was that this condition was named. Participants learned, for example, that Randy has dipathy, a condition defined by a tendency to imitate the actions of others, and so on. Participants were then asked to evaluate explanations. That Randy acted this way because he has this condition in the unnamed case, or the same claim with the inclusion of the label in the named case. They rated how satisfying the explanation was on a scale from 1 to 7. The key result was that participants rated the explanation better in the named condition than in the unnamed condition, even though the only difference between the two conditions was the inclusion of the invented label dipathy. On the one hand, this illustrates the shallowness of explanation. Participants rated the explanation with a label better, even though in one sense it didn't have any additional content. But I think participants were actually making a reasonable inference, that if there's a label, it points to the cause of the tendency to act in a particular way. So even if what that cause is unknown to participants, the explanation is effectively pointing to a difference maker. To test this, we ran another experiment in which we contrasted an unnamed cause condition with a named cause condition. For example, in the unnamed cause condition, participants read, "It turns out that Randy has a condition that causes a tendency to imitate the actions of others and obey commands directed at them, leading him to take the painting." The named cause condition differed only in including the label dipapathy. If participants prefer explanations with labels because they take those labels to act as pointers to causal difference makers, then we might expect the explanatory effect of a label to disappear in this comparison, because the unnamed case also includes a pointer to a causal difference maker. And that's exactly what we found. Once a cause was specified in both cases, the explanatory effect of a label disappeared. Hopefully that example helps illustrate at least one sense in which explanations can be underspecified, and one way in which they can identify a difference maker and thereby be judged more explanatory. At this point, I want to turn our human explanation-seeking tendencies on themselves to ask, why? That is, why should we have a practice of seeking and favoring information with this set of characteristics? In other words, what do our explanatory practices do for us? In most of my research, I've adopted a functional approach to thinking about explanation, focusing on the role that explanation plays in learning and reasoning. A first step is to recognize that for humans, explanation is typically embedded within a broader process of inquiry that looks something like this. We make a huge number of observations in thinking and interacting with the world, only a small subset of which prompt our curiosity. Curiosity can lead to exploration and information seeking in a variety of forms. A subset of the time, it results in what we call explanation-seeking curiosity, which prompts us to seek explanations. Seeking explanations can in turn, when successful, yield explanations, and those explanations can in turn have a variety of downstream consequences, such as leading us to revise our beliefs, to seek new information, to make particular decisions, to trust or distrust the source of the explanation, and so on. With this as context, we can re-ask our why question in a more precise way. Specifically, how might our explanatory practices affect belief revision, information search, and so on? And can we understand the properties of explanation by appealing to these roles? A complete answer here would take me well beyond the scope of this presentation, but I'll make 2 points to illustrate this framework. First, one thing I've argued in my work is that explanations have the properties they do, in part because these properties support generalization to new cases. That is, one reason we seek difference makers that differentiate what actually occurred from relevant counterfactuals is because doing so helps us identify factors that support prediction and intervention in the kinds of cases we're likely to encounter in the future. Again, let me make this more concrete with an example from my own research. In this project, we contrasted causal explanations that did or did not involve plausible causal mechanisms. To do this, we presented participants with evidence of a correlation between two variables, where we wouldn't expect them to come to the experiment thinking those variables share a causal relationship. For example, in one vignette, participants were asked to imagine that they were assistants to a museum director, and in the course of collecting data on museum visitors, they observed a correlation between whether or not a museum visitor visited the portrait gallery and whether or not they made an optional donation when exiting the museum. Here's an example of what the data might look like for a sample of 80 museum visitors. One of the critical manipulations was whether we offered participants a plausible causal mechanism linking these two. For example, in this case, half the participants learned about research in social psychology, demonstrating that exposure to faces, and particularly to eyes, triggers mechanisms associated with the maintenance of pro-social reputation, increasing cooperative behavior. So being in the portrait gallery surrounded by faces with eyes could make you more likely to donate than visiting other parts of the museum. Some participants were then asked to make an explanation goodness judgment. The exact wording varied across our studies, but here's one example. Participants read, "Based on the information you have, please rate how good you think the following explanation is. Why do some museum visitors make optional donations to the museum? Because they spend some time in the portrait section." They then rated this explanation from very bad explanation to very good explanation. Perhaps not surprisingly, This explanation was rated better when participants were provided with a plausible mechanism than when they were not. What I think is more interesting is the comparison between these ratings and those for a matched causal claim. Again, this varied across experiments, but in this experiment, half the participants were instead asked to evaluate how strong of a causal relationship there is between spending time in the portrait section and making an optional donation. The idea here is to have a judgment that's matched to the explanation claim in all sorts of ways, like the strength of evidence, prior plausibility, and so on, but not explicitly explanatory. So we can see whether the provision of a mechanism and mechanism information might play a particularly important role when it comes to explanation. That's indeed what we found. Although providing a plausible mechanism elevated ratings for both explanations and for causal claims, the effect was reliably bigger for explanation claims, and we replicated this across a number of experiments with variation in exact wording of the prompts. So, how does this relate to generalization? What we argue in the paper is that mechanism information plays a privileged role in explanation precisely because mechanism information offers a basis for generalization beyond the cases for which data have already been observed, what you might think of as out-of-sample generalization. For instance, suppose you were now asked to make a prediction about whether museum patrons who visited the sculpture garden were more likely to make an optional donation when exiting the museum. In the absence of a mechanism, you would likely make similar predictions whether the sculpture garden involved Rodins or Calders. But the mechanism gives you guidance for extending the explanation from the observed data involving the portrait gallery to this new case involving sculptures. Because the sculptures of people have faces and eyes that might trigger the same mechanisms as portraits, but the abstract sculptures do not, you might expect elevated donations in the former case, but not the latter. We tested this by having participants make generalization judgments to novel cases when they did or did not have a mechanism. We also varied whether the generalization was narrow in the sense that it involved an application to new instances like those already sampled, something like within sample generalization, versus broad, in the sense that they went beyond those initial cases. I don't have time to walk you through all the methodological details, but the key result was that mechanism information boosted both forms of generalization, but had an especially large impact on broad generalization. The upshot is that explanation might have some of the properties it does, such as sensitivity to mechanism information, because such information supports particular forms of generalization. The final point I want to make also follows naturally from this functional approach to explanation. As depicted here, explanation can have a host of downstream consequences, such as increasing a sense of understanding or increasing deference to the source of the explanation. The trouble is that achieving these ends can sometimes compete, such that the explanation that is best for achieving one aim isn't necessarily the explanation that is best for achieving another. One of my favorite examples of this comes from work by Lisa Scharrer and colleagues on scientific explanations. Across several studies, they manipulated the ease of comprehending scientific text by varying the amount of jargon. What they found was that boosting the ease of comprehension increased the extent to which participants professed agreement with the content of the explanation, but it also decreased the extent to which they advocated further information search or consultation with experts. So what seems on the face of it like a positive effect, increasing agreement and a sense of understanding, had a consequence that might be detrimental in many cases by leading people to have what was almost certainly a misplaced sense of confidence in their own ability to navigate the issue without further evidence or expertise. Again, the point I want to make with this example is that the same explanation won't always be optimal with respect to different explanatory functions. In the context of XAI and other applications, this means that it's especially important to be clear on what the goal of a given application is. This also suggests a shift in the questions we ask to guide research. For instance, instead of asking, "Is this the best explanation in this case?" where we begin with an analysis of the properties of the explanation or generic criteria for explanatory goodness. Instead, we can ask, what will best accomplish the explanatory functions I hope to achieve in a given application? This forces us to be explicit about what we're trying to accomplish and should help direct us to the features of explanations that are likely to matter in a given application, including how we might assess success. We've covered a lot of ground, so let me end with a summary of what I see as key take-home points. First, explanations are extremely diverse, but explanation seeking and evaluation are also highly selective and systematic. Second, explanations differ from descriptions and predictions in that explanations generate understanding, or at least a sense of understanding, in large part by identifying difference makers that differentiate the state of affairs from salient contrasts. We've seen several ways in which explanations are typically underspecified. They focus on a small subset of relevant factors, they leave a lot to be filled in by the recipient, and at least in everyday human cases, are generated under conditions of ignorance and uncertainty. I've also emphasized a functional approach, starting from the observation that explanations are just one step in the human process of inquiry. Instead of asking what explanations are, we can ask what explanations do, focusing on the functional consequences of explanation. One critical function is supporting generalization, and I've suggested that we can understand some of the properties of explanations in terms of their role in supporting generalization. And finally, explanatory functions can compete. The best explanation to achieve one function may not be the best explanation to achieve another. For this reason, I think it's crucially important for XAI applications to be explicit about what explanatory functions they hope to achieve and to take a function-first approach to constructing explanations. I'll end there with many thanks for your attention.
This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.